welcome to the video on the ideal gas law. This is sort of a staple in just about every chemistry book, and one of the laws that a lot of people remember, even past taking chemistry for quite a while. And basically, it is going to relate four properties of gases into one equation. So we've talked through, if you've watched the series of videos, we've talked through lots of laws and all sorts of things. So at this point, you've combined Boyle's, Charles, and Gay-Lussac's law into the combined gas law. So that's a main equation to know. And then we talked about Avogadro's law, which was being sure that we understand what standard molar volume is, and we have 22.4 liters per mole. And so now we're going to relate pressure, volume, moles, and temperature. So P, V, N, and T. We can combine these into a single equation called the ideal gas law, and it is PV equals nRT. So an equation you definitely want to know. And R is a constant. Okay, and so you will, if you're in my class, you'll either be given this number or allowed to write it down. You don't have to memorize it, but it is very important. And so typically, once again, for my class, this is the R that we use. It is equal to 0.0821, and then the units, this is the units for R: liters, ATM, moles, Kelvin. Okay, what I tell my students is, if you forget when you're doing these equations you forget what your units are supposed to be, go look at R, because your units need to match up with R. So liters, ATM, moles, Kelvin. Volume has to be in liters, pressure in ATM, quantity or moles in moles. So remember, grams and moles are not the same, so you have to convert if you're given grams. And then Kelvin, we've been using that. That's been common throughout for temperature. All right, so we know if we plug in R into an equation, our units have to cancel. Therefore, we have to match them with R. Okay, how many moles of gas are contained in a typical human breath that takes 0.50 liters of air at 1 atm and 37 degrees Celsius? Okay, so we identify our knowns and then figure out what we're looking for. So we're looking for moles. Okay, at this point we haven't really been solving for moles up until Avogadro's law. Okay, so pressure is 1, volume is 0.5, temperature is 37. We know we're going to have to convert that. Okay, so 37 plus 273 is 310. And we're looking for moles. So first thing I do is I check what I'm given. R is liters, ATM, moles, Kelvin. So I match up here, volumes in liters, pressure in ATM, and then I converted my temperature to Kelvin. Okay, so we need to convert all of our values to the proper units and choose the value of R that contains these. So temperature is in degrees C, but it has to be in Kelvin. So we already did that. We turned it to 310. Okay, and now we are ready to solve because all of our units match these here for R. So PV equals nRT. Okay, and we are looking for N. So when we rearrange, this is just algebra here, we have to get N by itself. So N equals PV over RT. Okay, so we divide both sides. Okay, pressure was 1 atm, volume was 0.50 from the problem. R is given, that's a constant, 0.0821, and temperature is 310 Kelvin. So if we look, liters cancel, ATMs cancel, Kelvins cancel, and we're left with moles, and that is what we are trying to find. So all of your units should cancel to give you what you're looking for. Okay, and if you do the math, you get 0.020 moles, and that is the answer. So it takes 0.020 moles if you're at 1 atm pressure, 0.50 liters, and at 310 Kelvin. Okay, let's do a practice problem. Okay, ask for volume. So right away, this is going to be my rearranged equation. Okay, for this one is really as difficult as it can get because you have to convert all of the numbers that you're given, all the units that you're given. So we have 50 grams of C2H6. Okay, grams is not the same thing as moles. We have to convert to moles. So if you add up the molar mass of ethane, C2H6, carbon's atomic weight's 12.01, hydrogen's about 1.01, and so we get about 30.08 grams per mole, which is 1.66 moles. Okay, so we convert grams to moles like we've been doing, or you've hopefully been doing all semester. Okay, so let's go ahead and plug that in. Okay, R is 0.0821 liters ATM moles Kelvin. That's our constant. Okay, temperature is 140. We've got to add 273, and so we get 413 Kelvin. Okay, pressure is in torr, and it has to be an ATM to cancel. There are 760 torr and 1 ATM. So we get 2.39 ATM. Okay, ATMs cancel, moles cancel, Kelvins cancel. We're left with liters, and that's what we're looking for. We're looking for volume. So when we do the math, we get about 23.6 liters. Okay, so PV equals nRT is the ideal gas law where we can relate all of these 4 properties of gases: pressure, volume, moles, and temperature. And if we're given 3 of those 4, we can always solve for the others. So you can rearrange in any way to solve for volume, pressure, moles, or temperature. All right, I hope this helps. Thank you.